So I originally was going to do something a little different for 12.2. I have a new worksheet that has videos that are embedded in the worksheet, but I didn't want to confuse anybody this late in the game. So I decided just to go ahead and make a video for like a normal video, like I've been doing all semester for 12.2. So let's get to it. So I am going to pull up the notes packet because there's going to be a need to look at the notes packet because we're going to have sets of data. We're also going to need to be able to kind of easily flip back and forth between the computer and then the calculator. So like the notes and the calculator. So I am on the laptop, which means it's a little messy, but we'll live, right? Okay, so this section is all about measures of central tendency. So it's ways to measure the center of a data set. And we have basically 4 ways we can do this. We have the mean, the median, the mode, and the mid-range. And they all do the same thing, but they do it differently. So like in a perfect data set, they would all be basically the same, but data sets are rarely going to be so nice. Okay, so it is important to know how to calculate these different measures of center and to understand in some situations why one would be more meaningful than another. Okay, so the first one we have is the mean. This is the sum of the data items divided by the number of data items. Okay, so imagine test scores. Okay, let's say you have test scores of 75. I need to annotate. 86, 81, and 90. So we would take those test scores, we would add them up, and then we determine how many test scores do we have. Well, we have 4 test scores, so we would divide by 4. So if I added these up, and I'm not going to go to the regular calculator, I'll just do this one quick on my actual calculator. 86, so we do 75 plus 86 plus 81 plus 90. We get 332 divided by 4. So we would get that our average test score is 83. And that seems fairly reasonable. If we look at this data set, 2 data items are less than 83, 2 data items are more than 83. So it would make sense that somewhere in the middle of that data set would be a score of 83. So that would be like your average test score. Okay. Now this notation right here, I don't want to flip you out by it at all. Okay. X with a little line over it, we call it X bar. Okay. And that's what we use to denote the mean. Okay. So at some point I'll do a video on calculator stuff and you'll be able to see pretty easily that in the calculator, they call the mean X bar. Okay. So if I ever say X bar, just know I mean the mean. Okay. This wacky little symbol right here just means add them up. It's the summation symbol. Okay. So it literally means just add up all the X's, where the X's are the individual data items. Okay. And then N is always, in this case, going to be the number of data items. You're going to see N show up a good bit in this chapter. So N is the number of data items. So this wacky notation that you see over here on the left, it is literally just shorthand for saying add up all the X's and then divide by the number of data items in your set, and that gives you the mean or X bar. Okay. So a couple of things that I do want you to know about the mean, and I'm going to go over to the whiteboard now. So a couple of things I want you to know about the mean is that it is very sensitive to outliers or extreme values. So the mean is very sensitive to extreme values. So again, remember, I'm on the laptop, which it makes it easier to bounce back and forth, but it is messy, okay? But we'll get by, okay? So what I mean by this is let's look at 2 sets of data. So this is kind of straying from your notes packet, but let's look at 2 sets of test scores. So let's look at student 1 versus student 2, okay? So let's say that student 1 had the following test scores. They had a 78, an 81, an 85, a 77, and let's do an 89. And then let's say student 2 had a 92, a 94, They had a terrible day. Their grandmother died. They were in a car wreck. I don't know what happened, but they ended up getting a 38. And then they had a 90 and an 89. Now, on the surface, to me, it looks like student 2 is the stronger student compared to student 1. But let's look at the mean to see how the low value here kind of impacts our final result. So X bar, we're going to take 78, add it to 81, 85, 77, and 89. And then we're going to divide by the number of data items in this set. We have 5 numbers. So again, I'm just going to use my regular calculator because I think this is fairly easy to follow along with. So 78 plus 81 plus 85 plus 77 plus 89, I get 410. And then I'm going to take my 410 and I'm going to divide it by 5. So my mean test score is 82. And that makes complete sense to me. If I look at this, there are 3 data items less than the 82. There are 2 data items that are greater than 82. This seems like a good representation of the middle of this data set. Remember, we're looking for measures of central tendency, so kind of like measures of the center of the data set. Now, for student 2, they had really good test scores. They had 1 B and then they had 3 A's, but then they had that one horrible day where their test score was really rotten. So for X bar here, we're going to take 92. We're going to add 94, 38, 90. That is an 89. It looks ridiculous, but it is an 89. And then we're going to divide by the number of tests. They again had 5. So 92 plus 94 plus 38 plus 90 plus 89, I get 403. Divide it by 5. And we get 80.6. Now, if you look at the surface of these test scores, does it make sense that student 1 would have a higher mean grade than student 2? Kind of not really, just at a glance, because student 2 clearly had overall much higher test scores. They had 3 A's, 1 really, really high B, and then they had that 1 really low test score. It doesn't really make sense because if we look at this mean, 4 of our data items are significantly higher than the mean, and then 1 data item is significantly lower. But that 1 data item, because it was so extreme, it pulled the mean down. So like if I did the same thing and I just took out the 38, so let's say I did 92 plus 94 plus 90 plus 89, and I divided by 4 instead of 5, we would get a mean test score of 91.25. So you can see that 1 low test score really pulled the mean down. Similarly, what if we had a fairly weak student, but they had 1 really, really high test score? It would pull their mean higher. It would make it look like their overall test scores were higher than reality. So that is one thing about the mean to always be cautious of. The mean is sensitive to extreme values. Those extreme values can pull the whole mean up or down. Okay, so let's go back to the worksheet because there is a set of data that I want you to look at. Okay, so we have an example here. It says, use the chart below to find the mean percentage of adults in the 10 countries who agree that inventiveness is inherited. Okay, so we do want to look at those that think inventiveness. Oh, I always forget to annotate. We want to look at those that think inventiveness is inherited. So we want to find the average of those countries. Okay, so let's see, we're looking orange. So we're looking at 8, 16, 16, 20, 22, 23, 23, 25, 25. We're going to add those up. Okay. So I've got 8 plus 16 plus 16 plus 20 plus 22 plus 23 plus 23 plus 23 plus 25, 25. Always double check yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got all 10 data items, and then I want to divide by 10. Well, that's kind of messy, right? And notice in this particular case that you have a few data items, or a couple of data items anyway, that occur more than once. So one thing that you can do is if you see a data item that occurs more than once, you can you can rewrite it, okay? So 8 only occurs once, so I'm going to do just 8. Plus, well, 16 occurs twice, so I'm going to do 2 times 16. 20 occurs once, 22 occurs once, 23 occurs 3 times, and then 25 occurs twice. So you can jump straight to something like what I'm just now writing. You're still dividing it by 10. There's still 10 data items. We just kind of found a shorter way to write this out. So in your calculator, let me see, I'm gonna have to flip back and forth a little bit here, but let me go to the calculator. Actually, hold tight. I'm gonna pause and get the actual worksheet in front of me. Okay, sorry about that. I decided to get the actual worksheet sitting in front of me so that I could flip back and forth easier. So what we had, let me go back to the worksheet. Okay, so I'm gonna have to re-annotate this, but you know, tis what it is. All right, so what I showed you is that instead of writing out each data item and adding them, if you have data items that repeat, you can kind of shorten the process here. So we could do 8 plus 2 times 16 plus 20 plus 22 plus 3 times 25, or 23 rather, and then 2 times 25, and then we can still divide it by 10, okay? Now, on your calculator, I'm going to move over to the calculator. Just know that this is going to disappear when we come back, okay? But we'll figure it out, no big deal. Okay, so I'm going to go to the calculator. And when you're doing the mean, it would be very useful to do that alpha y equals. Remember, we did a lot of that back in chapter 8. So alpha y equals, and then choose the first option. It just sets things up to where you have basically a fraction. So we're going to take 8 plus 2. Oh, it's not doing it. So 8 plus 2 times 16 plus 20 plus 22 plus 3 times 23 plus 2 times 25. And then in the denominator, we're going to get a 10. Okay. And that calculates our mean as just 201 divided by 10. So I don't know if this one's just automatically doing the fraction. Let me see really quick. So if we do 201 divided by 10, it should give us the decimal. It might be a setting that I have on this calculator. There you go. So we get that the mean of this is going to be 20.1. So let me go back to the worksheet. The back and forth gets kind of annoying, but it's what we've got. So there you have it. So here we found that we get 201 divided by 10, or an average of 20.1%. So basically it said, use the chart below to find the mean percentage of adults in the 10 countries who agree that inventiveness is inherited. So 20.1% of the people in these countries on average think that inventiveness is inherited. So of course we have data values less than 20.1. We also have data values greater than 20.1. So we have 1, 2, 3, we have 4 data values less than 20.1 and then 6 greater than 20.1. But this is approximately the center of this particular data set. Okay, so there you have it. All right. Now, another thing that I want to talk about is something that we talk about in a previous section. We talk about frequency distributions. Okay, so you kind of have to remember what a frequency distribution is. In a previous section, we talked about how to collect and organize data. And then in these coming sections, we're going to talk about how to analyze the data. So one way that you can organize data is in a frequency distribution. So this is a way to organize data based on how many times a data item, that's an item, occurs in a data set. Okay, so you can look at how many times an individual very specific data item occurs in a set, or you can look at how many data items in a particular interval occur. And when you're doing this, where you're looking at how many data items occur in a particular interval, you're doing what's called a grouped frequency distribution. So you can have just where you look at just individual data items, or you can look at data items in like a broader interval. The only thing is you want to make sure those intervals are consistent and they're like the same size. Okay, so let's go back to the worksheet. And we basically did that here. We kind of did finding a mean of something similar to a frequency distribution. So what I'm about to show you shouldn't be too wacky. Now, we have some weird notation here. Okay, we have X bar, which we know means, let me scroll up just a smidge. So we know that we have X bar, which means just mean. Okay. X represents the individual data item, and then F represents the frequency of that particular data item. Okay, so in this particular case, we're going to be looking at the frequency distributions where we look at very specific data items, not intervals. So we're going to look at specific data items, and we're going to multiply the data item by the frequency of how many data items, how many times that data item occurred, just like we did in the previous example. We had 23 that showed up 3 times. So instead of writing 23 plus 23 plus 23, we did 23 times 3. Okay, so you're taking each individual data item, multiplying it by how many times it occurs, then you're adding it up. That's that weird pointy E. And then you still divide by the number of data items in your set. Okay, so let's see here. All right, let me erase this really quick, and then we'll look at this example. Okay, so we've been given a frequency distribution, and we're told that we need to find the mean. Okay, the first row is the actual data item. The second row is the frequency of which that data item occurred. So the first thing I want to do is figure out how many data items I have. To do that, you just look at the frequency. 33 shows up 3 times. Well, 30 shows up 3 times. 33 shows up 4 times. 40 shows up 4 times, 50 shows up just once. So I have 12 data items total. Okay, so to figure out what N is, the number of data items total, okay, add up your frequencies. Okay, so what I'm going to get here for X bar is I'm going to get 3 times 30 plus 4 times 33 plus 4 times 40 plus 50 just times 1. And then all of that divided by 12. Now, I could do this where I do 30 plus 30 plus 30 plus 33 plus 33 plus 33 plus 33 plus 40 plus 40 plus 40 plus 40 and then plus 50. But that's a little bit longer and drawn out. So understanding how you can take a data item and multiply it by its frequency instead of adding them individually, it can be a little bit of a time saver. So let's see here. I'm going to do 30 times 3 plus 33 times 4 plus 40 times 4 plus 50. So I get 432 divided by 12. And we get a mean of 36. And that kind of makes sense. Out of 12, 7 of our data items are less than 36. 5 of our data items are more than 36. And remember, the mean is kind of sensitive. We have more of those lower values. So yeah, we're going to have, you know, a lower mean. Okay. But that makes sense. Even though we have values in the 40s and the 50s, it makes sense that our mean would be in the 30s because we had so many data items in the 30s. Okay. But there you have it. You can easily calculate a mean looking at a particular frequency distribution. Now, this is specific to the frequency distributions where you look at just individual data items, not intervals. Okay. So next up, we are going to stop annotating and we're going to, let me do this. This is easier. I think we decided this last time. And then go back to the worksheet. It clears everything out, which is a little bit of a time saver. Okay, so let's look at the next measure of central tendency. So the next one we're going to look at is the median. Okay, so the median is the true center of a data set. Okay, it's not going to be sensitive to outliers or extreme values. So you can have one really, really low value and the median is not going to be impacted by that. You could instead have a really, really high value. The median is not going to be impacted by that. We're really, truly looking at the center. Okay, so the first thing you have to do, and this is super duper important, is you have to arrange the data items in order. Okay, and you want to go smallest to greatest generally. Okay, if the data items, if there's an odd number of data items, you're going to be able to easily find one true center value. Okay, And then if the data item has an even number of items, then you're gonna have to do a little more work. So let's look at a couple of examples and we'll go from there. All right, so annotate. So the first data set, we have 1, 2, 3, 4, 5 data values. So we have n equals 5. When the data set has an odd number of data items, it's really easy. You want to put the data set in order, smallest to largest. So for this data set, I would go 25, 28, 35, 42. Nope, let me fix that. 40, then 42. Okay, so you have to put your data items in order. And then basically we just count off from each end until we get to that middle data item. So the middle of this data set is 35. You got 2 data items less than 35, exactly 2 data items greater than 35. You've got that 1 data item in the middle. Okay, now the next set is going to be slightly different. So if you look at the next set, we have n equals 6. Okay, we still have to put the data set in order, but you're going to see something happen here. So we want to go, let's see, 61, 72, 79, 85, 87, 93. So you want to put your data set in order, and just like in the previous example, just kind of count off from each end until you get to the middle. So 1 at the end, 1 at the beginning, 1 at the end, 1 at the beginning. Well, if we lop off another 1 at the end, 1 at the beginning, we don't have a value left. So if you get to the point where you have 2 data items in the center, you want to find the average of those 2 data items. So again, if your data set is odd, you're going to be able to lop one off each end until you get to this 1 data item in the center. If your data set has an even number of data items, you're not going to get 1 data item in the center, you're going to get 2, and we have to find the average of that. So the median here, we would take 79, add 85, because those are the 2 values in the middle. There's 2 greater, 2 lower than that, but we're going to find the average of these 2, and then just divide it by 2. So let's see, I get 79 plus 85, which is 164. Then divide by 2, and we get 82. And that kind of makes sense. 3 data items are less than 82, 3 data items are greater than 82. So even though this data item is not specifically one from your data set, this does represent a true center. Exactly half of your data is below, half of your data is above. Okay. So let's, again, we're going to flip back and forth a little bit just because it's quicker than erasing. All right. So for this next example, we're looking at the position of the data item. Okay. So it says formula for the position of the median, rather. I think I said that wrong. So we want to know which data item in the set is going to be the one that represents the middle. Okay. So what you do is you figure out how many data items you have. All right. And then you add 1 to that and you divide by 2. So remember, in that first example we looked at, we had n was 5. So we could take 5 plus 1 and divide by 2. So we would get 6 divided by 2, which is 3. Now I'm going to scroll up for a second, so it's going to look kind of stupid because I have this writing here. But if we look right here at example A, we had 5 data items, and we found that when we put the data set in order, it was the 3rd data item that was the median. So we put them in order. We had 25, 28, 35, 40, and 42, and we found that the median really was 35. Okay, and that would have been in the data set being ordered, it would be the 3rd data item. Okay. And then if we looked at the next one, the next example, we had 6 data items. I always forget to annotate. It's super annoying. There we go. Annotate. So we had 6 data items in that second example. We add 1 to that and we divide by 2. So we get 7 over 2, or 3.5. This says the median is between the 3rd and 4th data items. Okay, so let's, again, it's going to look kind of crazy because we're going to scroll up and this is just going to, the writing is going to scroll with us. But If we look at that second example that we did right here, remember we put this in order. So we had 60, again, I always forget to annotate. It's like, there we go. There we go. So we get 61, 72, 79, 85, 87, 93. And if we look between the third and fourth data item, we average those, we get the median, okay? So again, this formula here, n plus 1 over 2, it just tells you the position of your median. So which data item, whatever number you get, you count off, and that's going to tell you which one is the median or which two you need to average. So again, if I put this one in order, we had 25, 28, 35, 40, 42. So we had 1, 2, 3. We found out that the median had to be the third data item, which really was 35. Here we count 1, 2, 3, and then we go to the next one, 4, and we average those. And those two data items, the average of that's going to be your median. So again, this formula that I showed you down here, it just gives you the position of your median. Now, if you're dealing with a really small data set, it's not that big a deal. It's kind of stupid. But if you look at a big data set, this can actually save you some time. Okay, so let's look at another example. And again, I'm just going to flip screen so that erases itself because I don't feel like erasing it. Okay, so let's look. We're going to find the median of the data set, and then we're going to look at a frequency too. Okay, and the frequency distribution, this is where that position formula is especially nice. Okay, it saves you some heartache. So we're going to find the median of the following data set, and we're going to remember that the position formula is n plus 1 over 2. Okay, so this data set is already in order. What we have to do is just count the number of data items. Okay, you can see that from smallest to largest, it's in order, no big deal. So I'm just going to count from 1 to 26. How many data items do we have? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we think n is 19, but in this section, be especially careful. Let's count it again just to make sure it really is 19. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's 19. So we want to figure out which data item is going to be the median. Well, we would take 19 plus 1 divided by 2. 19 plus 1 is just 20. Divided by 2 is 10. So that tells me the 10th item is the median. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then after that, there should be 9 more items. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 items. You have 9 items. And that one slam jam in the middle is 5. So the median here is 5. And that's it. Okay, so the position formula can save you a little bit of time. So you're not like blocking one off on each end until you get to the middle. This just gets right to it. It says the 10th item, that's your median. Okay, now same thing here. We've got a frequency distribution. Okay, the first row is the actual data item. The second row is the frequency. Okay, so if I add up the frequency, that's going to tell me how many data items I have. So 42 occurs once, 43 occurs once, 46 occurs once, 51 occurs 3 times, 52 once, 54 twice, 55 twice, 56 twice, 60 once, 61 twice, 64 once, 69 once. So that tells me we have 18. I'm going to add it up again just to make sure, because if you count these wrong, your answer is going to be wrong. Okay. So 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we get that there are 18 data items. So if we do the position formula, n plus 1 over 2, I take 18, I add 1, I divide by 2. So I get 19 divided by 2. So then all you want to do is take 19 and divide it by 2, and you get 9.5. Okay, so that means the median is the average of the 9th and 10th items. Okay, so from smallest, we want to count until we get to 9, and then the 9th, and then whatever the 10th one ends up being, that's going to be our median. So starting under 42, I get 1, 2, 3, plus 3 is 6, 7, 8, 9. So the 9th item is 54. That means, and that got us to the 2. The 10th item is actually going to be 55 in this case. So again, 1, 2, 3 plus 3 is 6, plus 1 is 7, plus 2. That means the 8th and 9th items are 54, and then the 10th item would be 11. So the median is going to be 54 plus 55 divided by 2. So we're going to end up getting 54.5 as the median. Okay. So hopefully that makes sense. It can be a little weird when we talk about the position formula. Again, it's just telling you which data item is going to be your median. Okay. If you get a decimal on the position formula, it's going to be like, in this case, we got 9 and 9.5. So whatever's less than that and whatever's greater than that. So the 9th and 10th data items, those are the two you average to calculate your median. If you get a whole number with the position formula, just count to whatever that position is, and that's going to be your median. Okay. So we've talked median and we've talked mean. Okay. Let's see what is next for us. Mode. Okay, so the third measure of central tendency is the mode, and the mode is the data item that occurs the most often in a data set. So if you're looking at a frequency distribution, this would be the one that has the highest frequency. So whatever occurs most often. Okay, if more than one data item has the highest frequency, so like let's say you have 2 items that both have the highest frequency, the frequencies would have to be the same, then you can have 2 data items in a set that are the mode. If there's no data item that occurs most often, then the data set has no mode. You can have more than one mode, you can have no mode, or you can just have a single mode. And we're going to look at examples of each of those. Okay. So you don't have to worry about really putting the data items in order. However, it is always easier to see the mode if the data items are in order. Okay. Now in this first set, I'm going to go ahead and I'm going to put them in order. Okay. We have 3, then 5, 8, 8, 9, and 10. So if you do take a second to put your data items in order, it is easier to see the mode. You can see 3, 5, 9, and 10 always occur just once, but then 8 occurs twice. So we would say the mode here is 8. It's just the number that occurred the most often. Okay. If we look at the next set, we have 3, 3, 5, 8, 8, and 9. Well, 5 and 8 both occur only once, but if you look at 3 or 5 and 9 both occur only once. If you look at 3 and 8, they both occur twice, and that's the highest frequency in the table. So here we would say the mode is 3 and 8. Okay. Now in the next data set, we have 3, 5, 6, 8, 9, and 10. Each data item only occurs one time. Nothing occurs more than anything else. So for mode, we would say NA or none. Do not put 0. If you put 0, that would tell the reader that there is a data item 0 that occurs more than anything else. Say none or not applicable. Okay, but do not say 0. All right. So that's the mode. Mode is probably the easiest one. It's just the single value that occurs most often. If there are 2 data values that occur more than everything else and they occur the same number of times, you could have something that is bimodal or has more than one mode, or you could have a situation where nothing occurs more than anything else. So you'd have no mode. Okay. Now the final measure of central tendency is the mid-range. Okay. The mid-range is basically you look at the highest and the lowest data items and you average them. Okay. I will tell you, mid-range is sensitive to extreme values. Okay, so let's go to the whiteboard and I'll give you just a fake scenario and then we'll get to the actual problem on the worksheet. Okay, so I'm getting ready to, stray from your notes packet a little bit. Okay, so if we go to the whiteboard, Okay, we know that the mid-range is fairly sensitive to extreme values because you're looking at only the highest and the lowest. If most of your data set is close to the highest and you have one like really wacky low value, it can really mess things up. So let's look at, again, test scores. So let's look at student 1 versus student 2. And I'm going to make up new test scores. So let's say student 1 had a 76, a 79, an 82, an 85, and a 71. Okay. If we looked at this to find the mid-range, and I'm just going to call it MR, we look at the highest and the lowest only. The lowest test score is 71. The highest test score is 85. So I would take 71 plus 85 and I would divide by 2. Okay. So 71 plus 85, I get 156. I divide by 2, and we get that the mid-range here is 78. And that seems fairly reasonable. If we look at this data set, there are 2 data items less than 78. There are 3 data items greater than 78, 2 of which are really, really close to 78. So this seems very reasonable. Now, let's say we have student 2. Let's say they had a 95, a 92, a 41, a 93, and a 90. Okay, so again, we're only looking at highest and lowest. So if I was looking at the mid-range for this student, I would take 41 plus 95, I would divide by 2. So 41 plus 95, I get 136 divided by 2. And so in this particular case, this student's mid-range would be a 68. And that's ridiculous. If you look at this student, they had one bad test. Maybe they were sick and missed some class days, something terrible happened, but they had one test score that was low, but otherwise they had A's on all of their tests. However, their mid-range is a 68. So that mid-range is super duper sensitive to an extreme value on one end or the other. Now, if the student's fairly consistent, like student 1, and their test scores are all C's and B's, then yeah, it makes sense that their mid-range would be in the high 70s. So again, mean and mid-range specifically, they're fairly sensitive to those extreme values. So just be on the lookout for that. Okay. So let's go back to the notes. We're going to look at another example. All right, so the chart shows the average height of adults by country. Find the mid-range of the average heights shown. So remember, mid-range is just highest and lowest. So it looks like this table is in order, okay? So the lowest is going to be Croatia. The highest is going to be the Netherlands. And the mid-range for us, we're going to take 72.36, add it to 71.06. So again, you just take the highest and lowest and divide by 2. So let's see, 72.36 plus 71.06, we get 143.42. And then I divide that by 2, and we're going to get 71.71. So that would be the mid-range of this data set. And that makes sense. It looks like 3 data items are less than that, 4 data items are greater than that. That seems like a generally reasonable estimation for the mid-range. Okay. One more question, and I just want to clear this out. So I'm going to do the little trick where I switch screens and it just erases all on its own. Okay, so one more question where we have one data set and we're going to calculate all measures of central tendency. So it says the following data lists the calorie count for hot dogs from 17 brands. Okay, we need to find the mean, the median, the mode, and the mid-range. Because we're doing the mode and the median, let's go ahead and just put this data set in order. Okay, so hopefully I don't mess it up. So we've got 138, 136, 107 is the lowest. So we start with one. Dadgummit, I forgot to annotate again. It's like a curse. So we have 107 is the lowest. So then we had 138, 36, 35. And then that's a 5, I swear. 136. We have 138 twice. Make sure you get both of those. Do we have a 139? No. Next up would be 140. We have one of those. Anything else in the 40s? We have 46 and 47. So get rid of those. 48, 49, 50. We have 153. Anything else in the 50s? Nothing in the 60s. So then we do the 70s. It looks like we have 73, 72. So we're going to count those. We have 75 and 79. I don't see anything in the 80s. And then we have 190, 191, 192, 195. So the data set is now in order. Let's double check and make sure we've got 17 items. Again, just double check because the stuff you're doing isn't necessarily difficult, but you miss one little number, everything's wrong. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 hot dog brands. Okay, so for the mean, you want to add them all up and then divide by 17, okay? So I'm going to add them all up on a calculator. Ideally, at this point, pause the video, you add them up on the calculator, and then start the video over, and we should line up about right. So let's see, I get 107 plus 135 plus 136 plus 138 plus 138 plus 140, 146, 147, 153, 172, 173, 175, 179, 190, 191, 192, 195. I get 2707, but I'm going to be real smart and I'm going to add them up again, okay? Just to make sure I get the 2707 twice. And that is, pretend, okay? $27.07. I'm feeling good about it. We're going to divide by 17. And we get that the median calorie count for the hot dog brands is, let's do one decimal place, 159.2. Okay. Now the median, let's go ahead and do the position formula on this one. So we take the number of data items, we add 1, we divide by 2. So we get 18 divided by 2 or 9. Let's count and figure out what the 9th data item is in this set. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9. I get that the 9th item gives me a median of 153. Okay. So if I count after 153, 1, 2, 3, 4, 5, 6, 7, 8, I get 8 data items after that, 8 data items before that. Okay. So that is the median there. For the mode, we want to see if anything occurs more than anything else. And it looks like 138. 138 did occur twice. Did anything else show up more than once? I think that's it. So we would say that the median here is not the median, bless my heart, the mode is 138. Okay, so the mode is 138. Okay, and then finally for the mid-range, we're only looking at the highest and the lowest data items. So we're going to look at 195 and 107. So the mid-range, we do 195 plus 107 divided by 2. So we get 302 divided by 2. And we get a mid-range of 151. So if you look at the median, the mode, and the mid-range, or not the median, the mean, the median, and the mid-range, they're all fairly close. They're all in that 150s range. The mode is a little off, but again, the mode, it varies on its accuracy, okay? But with that said, that's how you do the mean, the median, and the mode, and the mid-range. Now, I do want to show you how to do some of this on a calculator really, really fast, just so you can see it. So the calculator will absolutely calculate the mean and the median, and then it'll pinpoint the highest and the lowest data value. It can also put your data values in order, okay? So let's go. I'm going to do the same hot dog numbers, So have your worksheet in front of you. All right. So what you want to do on your calculator is you want to find the alpha button, that's the green one, and then go to the right twice. There's a button called Stat. You want to choose Stat. It's then going to take you to this screen, and you have 3 menus. Hold on. You have the Edit menu, the Calculate menu, and the Test menu. Sorry, I'm choking up a little bit. You want to choose Edit. In the Edit menu, the first thing you have is Edit. So that's where you input your data set. So we're just going to choose Enter right away. Okay. And then I'm going to type in the data items. Okay. So again, we're going to do the hot dog calories, the last example. Well, is it not going to let me? Okay, so 173, 191. Again, you can pause the video and then do this and we'll meet back up. 192, 190, 172, 147, 146, 138, 175, 136, 179, 153, 107, 195, 135, 140, 138. Okay. So you do want to make sure you put these in L1, okay? And right here, as you're typing them in, it's going to tell you which data item you're on. So if I go up 1, you can see that L1 and then in parentheses, they have 17. That's the 17th data item. So we know we at least typed in 17 data items. So that's good because our list had 17 items in it. Sorry. Okay. The first thing I want to do is put this data set in order. Your calculator will put this in ascending or descending order if you want it to. So go back to the Stat button, okay? And if you look at option 2, it says Sort A. You can tell it to sort L1 in ascending order. So you're going to go down to option 2, hit enter, and then you want to put L1 in there. Now, this is the tricky part. If you look at the buttons, the number buttons above them, you'll see L1, L2, L3, and so forth. We want to do second 1, and that'll input L1 here. Hit enter, and then hit enter, and it's done. So now let's go back to the Stat screen and see if it really did put our data items in order. So we're going to go back to Stat and Edit, and now you can see those data items are in order. So if you have a data set that's a little bit big and clunky, type it into your calculator, double check it, and then you can do the Sort A, and it'll put whatever list in order in ascending order. Okay, so there you have it. You've got your data set in order, and you can just scroll down and it'll go all the way to the end. Okay, now I want to calculate some stuff. So I want to go back to Stat, but this time I don't want the Edit screen. I want the Calculate screen. So you want to hit the right arrow once and it'll move you over until, whoops, hit the right arrow. It'll move you over till the Calculate screen pops up. And what I want to do is 1 var stats. That's 1 variable statistics. Okay, so just choose the first option. Hit enter. It's going to ask you which list. It should be in L1. So make sure it says L1, hit enter. Don't worry about frequency list. Just hit enter and then calculate, hit enter. And here you have a ton of information. So the very first thing it shows you is X bar. Remember, X bar is the mean. So that's the mean of our data set. We got 159.2 for the mean calorie count. If you do EX, it just adds up all of your data items. So remember, when we added up all of our data items, we got 2707. If you took each data item and squared it and then added them up, that would be the next one. Don't worry about that. Don't worry about the next 2 for now. Next, it shows you N is 17. We did have 17 data items. It pinpoints the smallest, the minimum data item, which was 107. Ignore Q1 for now. It does tell us that the median of the data set is 153, which is what we got. And then it tells you the max data item is 195. So this calculator will put your data set in order. It will find the mean and the median flat out. Once you have it in order, you can kind of see what the mode is going to be. And then it tells you the highest and lowest data items. And if you can find the average of that, you can find the mid-range. So knowing how to do this stuff on the calculator can be a bit of a time saver. Okay. So that's it for measures of central tendency. Sorry, there were a few areas that were a little weird. Again, I have very limited technology and I just use what I've got. And so, you know, sometimes it's clunky. Make sure you watch the calculator part again, like watch it as many times as you need to understand the steps. I can show you again in class, but that'll do for now until I see you again. All right. So that's it. If you have any questions, email me. All right. Good luck.